Hello, this is Yash in Physics 2211, and this is my Lab 2 presentation about the motion of a falling object. So we'll start off with a little introduction here. So the overview of this lab is that we're observing an object drop from rest and moving somewhat slowly. So basically, it moves slower than as if we dropped a rock. There will be 3 models in this experiment, 2 predicted models through GlowScript, position versus time graphs, 1 with gravity only, 1 with gravity and drag, and then an observed position versus time model using a software called Tracker. So the physics principles used in this lab, we obviously have the position update formula, which is RF equals RI plus V average times T, but velocity will be changing in this formula, so we won't be focusing on that as much. So the ones we'll be focusing on is the velocity update formula, which is velocity final equals velocity initial plus F net over M times T, and Newton's second law and momentum principle, which can be written in any of these ways. So here's the first model, which depicts the only force on the object is gravity. So you can see the velocity update formula on line 74 and the position update formula on line 76. Here is the gravity and drag GlowScript graph. So we can see line 70 through 72 involve F net being force of gravity plus force of drag. We have the velocity update formula here and also the position update formula as well. So the way I did my experiment is that I dropped a pillow from the top of my closet to the floor of my dorm. It's about a 2-meter drop. The system would be my pillow, and the surroundings would be my room and like the earth around it. And here we have all the initial conditions here. So I calculated initial velocity of the object and plugged down the GlowScript as well. And I also have the initial force, or I guess the constant force with gravity, and the mass of the pillow as well. So here is the video of my experiment. So here we have the graph of all 3 models. You can see in blue is the observed model with tracker, and the gray and orange are the 2 predicted models. I'll go over some analysis in the next slide. So we can see here that all 3 models look like a variation of the y equals x squared graph, which is good because in this case, drag is going to be a squared proportion to velocity. So it'd be drag equals minus bv squared. And the time it takes to ground the observed model is in between both predicted models, which is a good sign as they're like within like hundreds of seconds of each other. So obviously there's room for error that I'll explain on my next slide. So some of the errors include the object may not have been a complete free fall, as there may have been some slight forces from my hand when dropping it. And there was some movement in the x direction as well. It didn't fall directly straight. And there's also errors with tracker as I'm clicking on the center of mass each frame, so there's room for human error with the software as well. What does it mean? So in this case, we're talking about terminal velocity, which basically means the force of drag exactly matches the force of gravity. So you can see here in this graph, the velocity versus time. In series 1, this is the gravity versus drag model where terminal velocity you can see as it flattens out. You can't see it in series 2 because it's a constant velocity because there's only one force, the force of gravity. So series 1 is a much better model to use in terms of determining terminal velocity. And you can see based on the free body diagram of my object that net force is going to be 0. And last but not least, what if the object was thrown downward initially instead of dropped? The terminal velocity would be the exact same, as there's still no additional forces on your object. The only forces are gravity and drag, even though you give it an initial velocity, but the terminal velocity is going to be the same as we're in the same system and surroundings. And that's the end of my video. Thank you so much for watching.